Hello everyone, welcome to my video. I'm going to talk about some of the basic robot concepts by using the Fanuc robot as example. Also, I'm going to use the 3D simulation software Handling Pro for the demonstration. Before I go into specific topics, I'd like to tell you about in my personal opinion, what do I think about the robot skills? I divide them into four different levels. The first level it will be the manually jogging. So that's the term we use to describe like how do we move robot around, right? Rotate the arm, move the toolings to the location you want, right? So that will be the first basic level. And from this video, I'm going to focus on this skill, this level of skill. All right. And then as we move on, I will talk about how do we test program. And more specifically, there's a term called touch up. And after that, we will move on some of the advanced topics. Frames is a very important concept. And we're going to talk about how do we set up two frames. And also on top, we'll talk about user frames. Those are very complex topic. And of course, later on, we will have to talk about the instructions with robot and how do we use that to program robot, right? So just give you a overview. All right, let's move on to the first one. How do we robot jogging with the coordinate system? That's another term they use in the Fanuc robot. More specifically, first two basic coordinate system, one is called join, the other one is called world. Those are the two basic uh, jogging method you have to learn at the beginning. Right? So first, let's talk about the joint coordinates. All right. So that's very easy to understand. Very common robot format is the six axis, right? There are six axes of them on there. So we call axis. They also use the term called join, right? So that's why you see that they use letter J to represent. So count from the bottom, there'll be join number one, J1. So basically, you can see here, that's the servo motor to rotate the robot from the base, right? From left to right and side to side, right? And then if you count from the base up, this will be J2, right? This robot controlled the joint number two. So that will move the whole robot body forward, lean forward or backward, right? And number three will be this one on the back. So this will raise up the upper arm this way or downward, right? So you can see from the bottom, J1, J2, J3, they are called major axes. So they have the bigger movement. They establish, they call the robot envelope, right? The working area. So you can use the teach-dependent keys to independently move those joints. Right? So if we continue on that, we are going to the they call minor axis, right? It's come from G4, 5, and 6. So uh, in this particular robot model, all the three robot servo motors are on the back. So J4 basically twists the arm from side to side, and J5 is here, right? J5 will move like a wrist, right, on your arm, right? So flip the hand up and down, right? So, and number six is the very last one. This one is called the face plate. So at the end of the robot arm, eventually that's gonna mount. That's where we're gonna mount the tooling on top. So with J6, you can rotate your tooling around, right? So these three axis, 4, 5, 6, they call minor axis. They control the orientation of your robot tooling. Right? So they have a small movement, but you can have a minor detail change with the directions of your tooling, right? So with the robot simulation, you can see very easily uh, control them. All right, how do we control them? All right, so this particular robot model I'm showing up here is very easy to spot the all the drawings, right? So this is number one, this is number two, right? So you already understand that. So when we use the teach pendant to jog the robot, so this is the teach pendant here. So first we need to turn on teach pendant, and there's a shift key, right? So those are details you can learn from the lab. But I want you to pay attention on the corner here. It right now it shows world. So that's the current coordinate system. So if we want to change, we have to press the key called chord key to change to different one. There are a few of them. So we first learn join. So once we switch to joint, press and hold shift, and then on the side, you have all the join keys. So right now you can see here, I'm highlighting J1, right? So when you press one of the J1, you will see robot start to move, right? You can, this is, let me speed up a little bit, 50%, you can see bigger movement, right? You can see robot rotation on here, right? If I release the key, robot will stop. So if I uh, change the view, maybe you can have a better view on the movement. All right, so if we look at the robot from the top to look down on the bottom, top view, so you can see J1 will control the rotation from side to side. I can even make a move faster. You can see here. So this is one way, rotate the robot, and then this is the other way, right? Positive and negative, two different directions. So this is J1, rotate around the base. And if we look at from different angle, look at the J2, right, controlled by this robot. So you will see on here that correspond to these two keys, robot will lean backward or forward, right? So you can see the movement is on here. It's controlled by this servo motor, right? And J3 is here. And this one will control the upper arm to different directions. So on the teach pendant, we can locate to J3. Shift, one of them will go downward, the other one will go upward, right? So this is J3 and J4, 5, 6 are on the arm on here. So you can imagine that 4, 5, 6, they move in differently but similar fashion, right? So that is 5 right now I'm controlling. 6, if I rotate, probably you won't see that because the tooling is um, symmetric. Unless I zoom in, if I zoom in here, if you look at the pointer, when I jog on the J6, you may see a little bit, right? You may see here, little bit movement on 6, right? So you can see some minor movement on here. All right, so this is the first way we can jog the robot, right? It's called joint. Very straightforward because we have 6 axes, so we can control them independently. But if you can press more than one key, like 2 or 3 keys together, of course they will move together, right? But not many people will try to jog robot in that way because you can use, it's hard to control them in the consistent way. And also you have other choice, right? So the second choice is what we call the world coordinate. So we can jog robot in the what we call the Cartesian fashion. So when we talk about Cartesian fashion, that means you have X and Y and Z, 3 dimensions. So of course, you will have the 0, 0, 0 at the beginning, they call origin, right? So notice here, origin is somewhere around the robot above the base, not on the floor, right? Later on, I will show you that. So that will be the beginning, 0, 0, 0. And then you will have one axis point to the positive X and negative X. On the other side, you will have positive Y and negative Y. So this is the 2 dimension, X and Y. And in 90-degree wisdom is the Z or Z axis, right? So one is positive, the other one is negative. So if you still remember the geometric you learned, and then that will be the same thing you learned from the high school, right? So when we talk about the robot world coordinate, there's a right hand rule. So we can predict the direction of the robot movement. When I talk about robot movement, I'm talking about the tooling, right? That's the robot normally doesn't move, right? So the base will stay there. So uh, as you can see on this picture, right? So first we need to put our right hand in this gesture, right? So all in 90-degree, and also pay attention the back of your hand, the wrist correspond to the back of your robot. And then your index finger point to the positive X, your middle finger point to the positive Y, your thumb point to the positive Z, right? So that has the corresponding relation between them. So we can have a look with the robot simulation. All right. So let me switch back here. So uh, that's the robot base. And if we look at here, this is the back of the robot. And I just talk about the right hand rule, right? So if you are remember that the right hand rule on here, right? So switch here, you can see uh, your index finger will point to the positive X, is this direction. And then that way is the positive, uh, that's a bad drawing. All right, let me redraw it. So that way, that's supposed in the same that same plane, right? Two dimension will be positive y, and in 90-degree wisdom will be the positive z. So that's the first right hand rule on here, and uh, probably it's really hard to look at from this position. Let me quickly, I'm going to show you how to do that later, right? But I just, right now, I need to quickly move to the home position so we can have a look on there. So let's see at this location, if we switch the coordinate system, notice here we are in world right now. Now I can speed up a little bit at 50%. So those keys before we use to join to jog the join J1. But once we switch the coordinate system to world, those two keys represent X, right? One is positive X, the other one positive Y. So if I press a hold shift, positive X, so this, look at this pointer will move that way, right? So that's what you will see on here. So that's positive X and positive a negative X, right? So let me switch maybe a different angle. You can have a better look. Let me clear out this. So again, if we look at from the top, right? So let me draw that. So this, if we look at these two dimensions, that will be the positive X, and that will be the positive Y according to the right hand rule, right? So shift positive X, you will see that robot is going in that direction, and negative X, go backward, right? And if I look at positive Y, so you can see robot moving to straightforward, right? Notice that that's different from join. Join movement will be the circular movement, but world is straight. You can see robot is maintain the straight line, right? So if you notice the marking on the floor, there are straight lines on here. So robot movement is follow that, right? So that's the uh, X and Y. Let me switch back on here. And if I jog Z, that will be positive Z, straight up, straight, all right, not circular movement. You can see that. Later on, the next video, you will see more clearly with numbers, all right. Now I'm just showing you the visual movement. So this is the uh, involved the right hand rule, all right? But there are more complicated movement with the world. It's called orientation of your tooling. So you can control the rotations around the three axes. So if you control the around X, there will be yaw, represented by W. Yaw, pitch, roll represent the rotation around X and Y and Z. They are rather complicated, really hard to understand, but we have to understand in the situation what we use that, because you can see here not only we want to change the to precisely control the location, sometimes we also want to have the rotation directions around the x and y and z. Then how do we determine the positive and negative, which is the second, I call that second right hand rule. So because those six keys I just demonstrate the x and y and z like this. Right? Then if we want to decide the rotation, that'll be the second right hand rule. That'll be the lower six keys on here. So for each rotation, you can see here, rotate around x, you can have the minus x rotation, and also you can have the positive x rotation. Same thing for the y and z. Then how do we determine the rotation direction, right? So first, just like regular first right hand rule, that'll be what you do on here. Then you need to choose which axis you want to rotate around. So in this picture, particular picture, it's trying to rotate around Z, because second one is that to replace the finger or thumb designate in the right hand rule for the axis you select with your thumb. So it's really hard to read from this. So for example, right now, this hand gesture is trying to determine the rotation on Z. So Z is there, it's on the thumb, right? So then you keep the thumb, stay there. You don't move your thumb, right? Because you want to rotate around Z. And then when you curl your hand, your other fingers, like you can see here, that curl direction is the rotation positive direction. So that's why right now you can see this hand actually is correspond to this. That's positive Z rotation, right? I know it's sometimes it's really hard to understand at the beginning. Uh, that's why I have some videos try to let you to understand uh, the rotations. Let me bring up. Hopefully that will help you. All right. Those videos I shoot from the robot trainer. Right. So from this robot trainer, you can see this is the back side of the robot. Right. First, you need here. This is back. Right. This is back. This is front. And if you understand the first right hand rule, right. So this will be your positive X rotation. And that will be your positive Y rotation. And then on top of that is the Z, positive Z rotation. All right. So right now we're trying to rotate around Z. If we rotate around Z, we use your thumb to represent the positive Z from the first right hand row. And then the other four fingers will curl this direction. So that'll be the positive Z rotation. So that means robot tooling center point called TCP will remain here on top of the white stick, and then the whole robot body will rotate in this direction. All right, so I'm going to play the video. You will pay attention here. TCP stay, remain here. Then the robot will rotate this direction. So that'll be the positive rotation. Let me clear that. So let me play the video for the positive Z rotation. So you can see here, rotate around the stick. Right? It doesn't move away. it just rotate around with the positive direction, like I mentioned before. So it start around there, right? It rotate in this way. That's exactly your finger indicated if you put in the right direction, right? So of course that the negative Z rotation, next video I'm going to play is the opposite direction, right? So that will rotate around Z, right? Because you can see here, let me show that. So that will be the Z, right? Or Z, right? So that's rotate around that, right? Okay, so this is the uh, rotation around Z. Let me finish here. Go back here. That's the beginning, right? So that's Z. Then let's look at the rotation around X. That's the next two I'm going to play. Like I mentioned before, the X is positive X is this direction. This is positive X. So if you use your right hand rule, use your thumb. So thumb, I use T to represent. Then when you point your thumb to this direction, the other forefinger will rotate this direction. Right? Curl this direction, that'll be the positive rotation direction. Let me switch to the positive X rotation. So let's start from here. You can see robot will rotate. So TCP again, TCP will remain here. Robot body will rotate this direction. Right. So that's play the video. Look at there. So rotate. Again, TCP doesn't move, rotate around this direction. So you start from here, right? Rotate around this direction. All right, let's move. That, of course, negative X rotation will be the opposite. Rotate from this side, rotate to the other direction. All right, so next I'm going to play the Y rotation. Y rotation is a little bit hard to look at from this angle, but if you pay attention, you may find out on there. So let's look at here. So you can see right now is TCP is here. So if I draw that rotation, there'll be this way. It's really hard to represent. I'll let you to observe it. Then let's look at the movement. All right. So positive Y rotation is here. So again, TCP stay there, and then robot arm rotate. You can see this part, right? It's getting close to you. Rotate there, and this is positive Y rotation, right? And the other side is the negative Y rotation. Right? It takes some time to comprehend it and remember that and understand it. Right? Every year I see those people, they can get this point very straightforward, very easily, but will take most people some time to get used to this movement. All right. So this is the first video I'd like to talk about it. All right. So I will have more uh, topic I will talk about later. All right.